I'm Amber from Team Wetsuit, and this is our project Reforestation Robots. We've designed a coordinated system of robots to make reforestation more efficient and sustainable. You'll meet the rest of the team throughout the presentation. Reforesting damaged land is challenging due to hard-to-reach terrain, low seedling survival, and limited long-term monitoring. These issues hinder restoration and increase costs. The primary customers experiencing these issues include environmental organizations, government agencies, reforestation teams, researchers, and volunteers. Basically, anyone responsible for restoring large areas of land efficiently and safely. Across the field, several issues consistently arise. Hard-to-reach locations, low germination rates, labor-intensive planning, and minimal real-time ecological data. Existing tools also struggle with battery life, payload limits, and changing weather conditions. Our system addresses these challenges with autonomous navigation, precise seed and nutrient placement, built-in ecological sensing, and coordinated multi-robot workflows. Altogether, this reduces manual labor and improves long-term reforestation outcomes. To address every stage of reforestation, we designed a 4-robot fleet: Mycelios for scouting, Root Rover for planting, Flying Feeder for nutrients, and Arbor Guardian for monitoring. Now I'll pass it to Bo for a more detailed explanation of the fleet.
Hi, I'm Bo from Team Wetsuit, and I'll briefly be discussing the function and purpose of each individual robot in our swarm. The first of 2 primary robots is the Mycelios. This ground-based drone serves 2 main purposes: to search for valid locations to plant seedlings by using soil sensors, and working to repair areas that are not by dispensing beneficial fungal spores. The second ground-based unit is the Root Rover. This robot is the main workhorse of the fleet and navigates to the areas deemed acceptable by the Mycelios and plants seedlings using a system comprised of a front-mounted soil opener followed by a rear-mounted flap that serves to realign the disturbed soil with the seeds being dispensed between the two. The remaining 2 robots serve as support drones, and the first is the Flying Feeder. As the name suggests, this plane-style drone flies to areas where seedlings are planted and dispenses water and liquid fertilizer as needed. And finally, the second support drone and last of the 4 robots is the Arbor Guardian. This quad-rotor drone is responsible for monitoring locations where seedlings are planted for threats using its camera. It can deter animal threats on its own with its onboard speaker or send remote alerts back to operators for more serious threats. And with that, I'll pass it over to Kai for a detailed demonstration of how our robots collaborate in real time.
One of the things that makes our robots stand out is their capability for collaboration. When they operate, they are constantly communicating with each other and their operators to ensure maximum output with minimal waste. First, the Mycelios drives across the area to be seeded, checking soil health and replenishing when needed. The Root Rover follows close behind, using data from the Mycelios to plant seeds in the optimal locations. Afterwards, the Flying Feeder uses the same data to regulate its fertilizer and water dispensers for different areas. Finally, the Arbor Guardian takes the Root Rover's data on planting locations to generate an efficient flight path for monitoring the new seedlings.
Drone Seed focuses on dropping seeds from the air with drones, which lets them cover land fast but makes the placement less accurate and doesn't allow nutrient delivery. On the other hand, Dendra maps the terrain and fires seed into the soil, which gives better contact but still doesn't measure moisture or nutrients well. Comparing these two helped us understand what's missing and where our design can stand out. This slide shows what our system adds on top of what the competitors do. Because our robots work on the ground, they can sense soil, moisture, and nutrients before planting. We also split tasks across multiple robots, so the whole process becomes faster, more accurate, and easier to adapt. Ground level planting gives us better depth control, it's safer than manual work, and overall, it's more cost efficient than relying only on drones. To wrap everything up, our robots use soil data to guide where and how seeds are placed. Each robot has a role in a simple workflow: scouting, planting, nutrient delivery, and monitoring. The system reduces labor, handles tough terrains, scales to big areas, and keeps collecting data after planting to help track long-term growth and ecosystem health.